Indices. Today we are going to look at the topic of indices, and as we begin to look at this topic, we would like to ask ourselves, what is the meaning of this particular term in mathematics? Indices is generally the plural for the word index. And then what is an index? An index is a power to which a number has been raised. That is, for example, in the following expression, a squared, or a to the second power, or a to power 2, the a is called a base, while the 2 is called the index of the following number. And in some cases, if you don't find the word index, you may find the word exponent. I hope we are okay up to that point. So an index is the power to which a number has been raised. So if here given number, say a, is to the second power, the 2 becomes our index and our a becomes the base. And if we are to take a real number, for example 9 to power 4, 9 is our base number and 4 is our index number. And when we look at this particular topic in mathematics, there are certain laws that guide us on how to look at questions that are involving indices, and there are a number of them, and we shall be able to look at each one of them with the various examples. The laws, indices, and the first law that we shall look at is called the multiplication or product law. Or multiplication law. And it goes like this. If a number, say a to the power m, multiplied by the same number a to the power n, what do we get? You get that same number a, but since the base is the same, we are actually finding the product, what you will do is that you will write the same base here, and then you're going to add the powers, or what we call the index of the numbers. If the base is the same, the indices are added. That is what the product law or multiplication law entails. Examples: if we have a number like 8 to power 2 times 8 to power 10, and the question is evaluate. So how do you go about it? Solution: since the base is the same, you'll simply rewrite the base, but the indices will be added. and that becomes our answer. And we are done with the first law. Let us go and look at the second law. The second law is called the division law, or the quotient law. And when we are looking at this particular law, one thing that we need to know is that if the base is the same when dividing two given numbers, the index of the divisor is subtracted from the index of the dividend. What do you mean? Let us look at this this example. If we have a number, say a to power m divided by a to power n, as you can see, the base is the same. So if the base is the same in the two numbers, what you'll do is just to rewrite the base there. But in this case, we shall subtract the indices. And which number shall be subtracted from the other? The index of the divisor, this is our divisor, is subtracted from the index of the dividend, and therefore it shall be m minus n. Let us look at an example. Let us look at an example. If we have a number like 2 to power 3 divided by 2 to power 2, how do you go about it? We have said that if the base is the same, according to the division law or quotient law, you'll simply write the base. If it is 2, 2, of course the answer will still have the base of 2. But when we are looking at division law, it is actually opposite to the product law. And what will happen is that the index of the divisor will be subtracted from the index of the dividend. So you'll just take 3 minus 2, which will be 2. 3 minus 2 will be 1, which will be 2. And that will be our answer. The third law, it is called the power zero law. The power zero law, and it is written like this: any number to power 0 is simply 1. And what the power zero law entails is that the value of any number raised to the power 0 is 1. And so, for example, if you are given this particular number, 985 to the power 0, the answer is 1. If you are given 295 to power 0, the answer is 1. If you are given 10 to power 0, it is 1. And lastly, if you are given 25 to power 0, it is 1. And that's about it. We go to the fourth law. It is called the power 1 law. And what this law entails is that any number raised to the power 1 is that number itself. Say any number to the power 1 is that number itself. Examples: if we have 8 to power 1, the answer is still 8. If we have 100 to power 1, the answer is still 100. If we have 81 to power 1, the answer is still 81. And that covers the fourth law. The fifth law of indices is called the two powers law. And what we normally say when we are looking at the fifth law, which is the two powers law, is that if a number with a power is raised to another power, the indices are multiplied. If a number with a power, say m, is raised to another power, say n, the indices are multiplied. Or and that is how that law is represented. That if a number, say a, with a power, say m, is raised to another power, say n, what you just need to do is multiply the powers. Let us look at a few examples. If we have 2 power 3 raised to 2, what you simply need to do is solution. You just take 2 power 3 and then you remove the bracket by multiplying the indices and you'll get 2 to power 6. Second example, if it is 3 to power 2 and this one is squared, the solution, it will be 3 to power 2 times 2, which will be 3 to power 4. And that covers it. Let us look at the sixth law. It is called the power of a product or the fraction law. It's called the fraction law or the power of a product, and it is represented in two ways. We shall start by looking at the first one. If we have a number a, b, power m, it can be represented as a to power m times b to power m. And what we say in this first part of the fraction law is that if a product is raised, the product of a and b, if it is raised to a given power, each of the factors is raised to the same power. Let us look at an example. Simplify 3b to power 2. So if you ask to simplify this, what you need to do is that 3b squared, and we have said that if a product is raised, the product of 3 and b is raised to a given power, each of its factors is raised to that same power. So we shall have 3 squared b squared, which is equal to 3 squared times b squared, which is equals to 3 squared is 9, b squared. And we are done with that. The second part of the fraction law, or the power product law, is represented as follows. If we have a number a over b, a fraction, to a given power m is equals to a to power m over b to power m. And in this second part, we say that if a fraction is raised to a given power, if our fraction a and b is raised to a given power, both the numerator and the denominator of the fraction are raised to that same power, as you can see on your screen very clearly. And therefore, if we have an example, simplify squared solution, what happens is that if we have 3 over 4 squared, it will be 3 squared over 4 squared. 3 squared is 9 over 4 squared is 16, and this becomes our answer. So this first part is referred to as the power of a product law, and this second part is referred to as the fraction law. Let us look at the seventh law. Which is called the negative index law. And here we say that a number raised to a negative power equals its reciprocal with a positive power. And it is represented as follows. If we have any number raised, for example, a raised to power negative m, it is equal its reciprocal with a positive power, and is written as follows, like that, or 1 over a to power minus m, which is equal to a power m. We can look at an example. Simplify six power minus 4. And how do you go about it? This one, we have said that if any number, and our number here is 6, is raised to a negative power, it equals its reciprocal. What is the reciprocal of 6? It is 1 over 6. But the sign of the power changes and becomes positive. So when you put in your calculator 6 to power 4, you'll get it is 1296. Part B, if you have a fraction like 1 over 5 power negative 3, how do you go about it? This one simply becomes, if you want to rewrite this particular number as a whole number, what you will need to do is that you'll bring the 5 to be the top, and then the sign of the power will change to become positive, just like that. And then when you put in this particular figure in your calculator, you'll get 125. One thing that you must note with this particular law is that if we have a number a over b to power minus m, it is equal to 1 over a minus a over b to power m. It is equals to 1 times b over a to power m is equals to b to power m over a to power m. Kindly, I request, if there need be, pause the video to look at it carefully and see, by applying the various laws we have looked at, whether it makes sense up to this particular point. And we can do an example in this particular case. If we have a number like evaluate 2 over 3 to power minus 3, because you already know the outcome based on our formula up here, what you just need to do is just to apply it directly which will give you 3 power 3 over 2 power 3. 3 cubed, it is 27, over 2 cubed, it is 8, and the answer will be 3 and 3 over 8. At any position of the video, if you feel you need more time to be able to look at it, kindly pause the video for you to be able to understand it better. Let us look at the 8th law. The 8th law is called the fractional power law. And this particular law is represented as follows. It is divided into 2 parts. If we have a number a to the 1 over n power, it can be written as the square root of a to the nth root. Note that if n n is equals to 2, the power is equals to a half, which represents the square root of the number. That is a. If n is equals to 3, the power is equals to 1 over 3, which represents the cube root of the number. That is if n is 4, the power of the number will be a quarter, which represents the fourth root of the number a. And that is why this law is applicable as one of the laws of indices. The second part of this particular law if a given number a, which has a power of m over n, we're saying it is equal to a to power 1 over n. You can factor out the m outside as a power, which is equals to, when we apply what we have just learned at this particular stage, this simply means but the power, remember, is still there, like that, or that is another representation of that particular expression, and we are saying where 1 over n represents the nth root and m is a power. I hope we are together up to that particular point. If you're writing and maybe I may be going a little bit faster, kindly feel free to pause the video, write as much as you'd love to write. Remember, in mathematics, as much as we may look at it theoretically, you have to practice using a sample of questions. Let us look at examples of this particular law. Simplify the following. Simplify the following. Part A, we have 8, 81 and 3/4. If we are to simplify this particular number based on this particular law, the fractional power law, solution, what we need to do is that we need to separate the powers as we did on this particular point, and so we shall have the fourth root of 81 cubed, which you may find the fourth root first and then cube it afterwards. The fourth root of 81 is 3, and because it was cubed, you'll write 3 cubed, and 3 cubed is equivalent to 27. Let us look at our second example. Two power 6, all of it to power a half. How do you go about it? You will have to apply the 2 powers law. and therefore you will open it up it will be 2 power 6 times power a half, which will give you 2 to power 3. 2 to power 3 is 8. And therefore, this becomes our answer using this particular method. Somebody else may opt to find to be able to find 2 to power 6, which will give them 2 to power 6, which will give them 64, and then they find the square root, or 2 power half, which will give them 8. But if you don't have a calculator, this is the most appropriate method to use when dealing with indices. So in summary, when solving equations involving indices, when solving equations involving indices, there are a couple of number of things you need to note. Number one, these are tricks that you can apply and you should apply. You need to collect like terms together. Number two, you need to apply the laws that we have looked at of indices. Number three, factorize where necessary. And number four, equate powers when the bases on both sides are equal, and find the unknown. So these are the 4 tips that I'm advising you, my viewer, to use to help you easily navigate the equations or equations involving indices. You need to collect the like terms together. You need to apply the laws of indices. You need to factorize when necessary and equate powers when the bases on both sides are equal, and find the unknown. Why are we saying we find the unknown? In several cases, you'll find you're given an equation where you're supposed to find an unknown. It can be in the case of the power or in the case of what we call the index. I hope this video has been informative. For more videos like this one, kindly engage with us on the comment section and we shall be able to get back to you. If you have questions, you can still type them in the comment section and I will be able to address them. If there are any challenges concerning indices or any other topic you'd like us to go through, kindly reach out to us in the comment section and we shall be able to address.